This section is on multiplying and dividing rational expressions. To illustrate this point more accurately, I think it's helpful to start with some multiplication problems that you probably already know how to do. For example, all of these fractions are just simple fractions with numbers. So no variables, no factoring, nothing super difficult. These are all things that we would know how to multiply right now. Remember, for fractions, you multiply straight across the top, straight across the bottom, and that's how you get your product, your new fraction. So if I multiply 3 times 2, I would get 6. If I multiply 5 times 7, I would get 35. So the answer to part A would be 6 over 35, or 6/35. Similarly for B, we could do that exact same thing, but if you notice right away, we see that there's a 3 in both the numerator and the denominator. So like we learned in the last lesson, when the numerator and the denominator share a factor means multiplication is occurring. So when there's multiplication, we are allowed to cancel. When they share a factor, we can cancel them out. So if we cancel out the 3's right away, we are left with 2 in the numerator and 5 in the denominator, and that fraction is simplified because we canceled right away. Part C doesn't necessarily look like we can cancel right away, but if we remember that 9 is the same thing as 3 times 3, then we see that we have a common 3 as a factor that we could cancel. So that's just a slightly different way of simplifying something similar. So in the numerator, we'd still be left with a 2, and then in the denominator, we would have a 5 times only 1 3 left, and then this is as simplified as possible. So we could have multiplied straight across the top and done 3 times 2 to get 6, and 5 times 9 to get 45, but we would have then had to simplify this since 6 and 45 are both divisible by 3, and we would have ended up getting 2/15 anyway. So the point here is that it's oftentimes easier to cancel before you multiply than it is to wait until you've already multiplied and then try to cancel things. So again, look for those opportunities. 3 times 3 is the same thing as 9, so those factors all completely cancel. Remember, since there's nothing left in the numerator, we would just say that there's a 1 there, and then a 5 in the denominator. So again, here was like kind of the general rule. It's smart to cancel before you multiply than it is to simplify at the end. So if we try that, I think the work for these can get kind of messy, so try and bear with me here. But as we look at the factors we have currently, this is all multiplication, so we're certainly allowed to cancel whenever we see fit. I noticed that 2 and 8 are both divisible by 2. So I can cancel out a 2 from both of them, which would leave me with a 4 in the denominator, since I essentially just canceled out the factor of 2. Same thing for 3 and 15. 3 is a factor for both 3 and 15, which means we would only have a 5 left with that 15. Kind of the same thing with the x's. We see that we have an x squared on the top and an x squared on the bottom. We can cancel those. We also see that we have an x to the 4th and an x to the 3rd. That, again, remember, looks like 4x's on top, 3x's on the bottom. So essentially 3 of them are going to cancel, and we're only going to be left with 1 on top. So I might just write that as just a 1x on top to remind myself that all of those canceled except for 1. Same thing with the y's. I've got 5 on top and 2 on bottom, so only 2 are going to cancel, and I'll be left with 3 in the numerator. So the work for this looks messy, but the way I have done it, there are certainly other ways that you could probably make it look better. But now we're looking for what we have left over. We have an x, y to the 3rd, and a 5 on the top. So I'll write that 5x, y to the 3rd. And then in the denominator, we have a 4 left, and that looks like that's it since all of the other variables canceled out. So the final answer for part A would just be 5x, y to the 3rd over 4. Part B, we see a lot of addition, which should kind of be a red flag. Here's my red flag I'll draw. Because remember, we are not allowed to cancel with addition. We're only allowed to cancel factors. So our goal is to always factor first. Remember, we kind of said the rule of thumb was to try and reduce or cancel before we multiply. if we want to reduce, we need to have everything in factored form. As I look at x plus 2, there's nothing more I can do to factor that, nothing I can factor out, so I'm going to leave x plus 2 alone. Though when I look at the denominator, I see that both 3x and 12 have a 3 in common. So I could factor out a 3 from both of those, and I would be left with x plus 4. And the second fraction, x plus 4, cannot be simplified anymore, so I'm going to leave that alone. However, the bottom has x squared minus 4, which is a difference of squares. We could write that as x plus 2 and x minus 2. So now this is all multiplication. As you can see, we've got everything in the factored form. Everything's being multiplied. We are now allowed to cancel common factors. So the x plus 2's can cancel, and the x plus 4's can cancel. Again, since there's nothing in the numerator, everything is canceled. We're left with just a 1. And then in the denominator, we have a 3 and a factor of x minus 2. So remember to keep that in parentheses since it is a factor. And that would be our final answer for part B. I'm going to ask that you go ahead and pause this video now and try some of these on your own. The factoring here is a little bit more complicated, so keep in mind you should be factoring at all times. But go ahead and try and factor these and press play when you're ready to check the answers. Okay, here you can see the answers for those 3 practice questions. The first one, I left the work in there so you can see how the factors canceled. The last 2 I did not. So if you have questions about those, certainly don't hesitate to reach out. Let's continue our notes. So the next part, you can see deals with division. Dividing fractions is typically a tricky thing. Remember, we don't like to divide fractions. We cannot just simply divide straight across the top and across the bottom like we did for multiplication. So for division, remember the idea is that we want to multiply by the reciprocal. Remember that the reciprocal is just the fraction flipped. A lot of people at DSST call this copy dot flip. That would mean you would copy the first fraction, you dot, so multiply instead of divide, and then you flip the second fraction, so copy dot flip. So in this scenario, nothing would have canceled out there. We don't cancel over division. We always copy dot flip. We just cancel over multiplication. So here we have turned this into a multiplication problem, and then this is exactly like the last section. So this section, again, is exactly the same. It just has this one added caveat where you have to copy dot flip first. So here we would end up with 16/25, which does not reduce. In part B, when we copy dot flip, we can see that we have a common factor of 4 in both the numerator and denominator, as well as 5 in both the numerator and the denominator. So the answer here would just be 1. As we copy dot flip in part C, again, remember we want to look for common factors. So if I notice that 5 and 10 are both divisible by 5, we would be left with a 2 in the numerator. So when I multiply straight across the top, I would end up with 8, and straight across the bottom, I would end up with 15. Let's go ahead and try some of the more difficult rational expressions where we've got both variables and numbers. So since this is division, we copy dot flip. We copy the 4x to the third over 9x squared y. We dot, and we flip 9y to the fifth to the top and 16 to the denominator. So here's I'm looking for common factors to cancel. Oops. Sorry about that. As I'm looking for common factors to cancel, I see that 4 and 16 have a common factor of 4. We'd be left with just a 4 in the denominator. I see that the 9's cancel. I see we have a y to the fifth and a y, which means one y would cancel, so we'd only be left with y to the fourth in the numerator. And then for x to the third and x squared, 2 of those x's would cancel, so we'd be left with just 1 x in the numerator. So as we look at what's left over, it looks like we had an x, y to the fourth in the numerator, and in the denominator we only had a 4. So this rational expression would be considered completely simplified as there are no common factors remaining. Part B is a tiny bit more difficult as it requires factoring first. I know this because there's subtraction in there, and anytime I see subtraction or addition, I should be thinking to factor. So let's go ahead and factor this first, and then we can copy dot flip. In the numerator of our first fraction, I see that there's an x to the third in common. We'd be left with x squared minus 4. X squared minus 4, though, is a difference of squares. So I'm going to go ahead and change that to be x plus 2 and x minus 2, as we're all familiar with factoring a difference of squares. In the denominator, I'm looking for things that multiply to be a negative 2 and add to be a negative 1. That would be negative 2 and positive 1. So that expression factors to x minus 2 and x plus 1. For our division, in the numerator, I see that the greatest common factor, so the term or the factor that all of these terms have in common, would be an x to the third. So I can factor that out first. I'd be left with x squared minus x minus 2. You may recognize this x squared minus x minus 2 as the same expression we just factored. So I'm going to go ahead and write that this factors to x minus 2 and x plus 1 as we just factored it to that. And in the denominator, we have a difference of squares. So that would factor to x plus 1 and x minus 1. So hopefully your factoring skills are sharp. You're going to want those for this unit for sure. But we are now ready to copy dot flip. So we can copy our first rational expression. We can dot, and we can now flip our second rational expression. So the denominator and the numerator are switched. Remember, we said that the numerator would factor to x to the third, x minus 2, and x plus 1, and that is now in our denominator as we have copy dot flipped. So as I look for common factors, I see that the x minus 2's may cancel in the first part of the rational expression. I see the x to the thirds may cancel. I see, oh no, sorry about that. I see that the x plus 1's can cancel, and that looks like about it. So I would be left with an x plus 2 in the numerator, an x minus 1 in the numerator, an x plus 1 in the denominator, and an x minus 2 in the denominator. And this expression would be considered completely simplified because there are no more factors in common. Remember, we cannot cancel out these x's just because we see them in both the top and the bottom, because there is addition there. When there is addition in the problem, you may not cancel. It is simply factors that you may cancel. Again, I'm going to ask that you pause and you write these ones down and try them. And as soon as you're done trying them, you can go ahead and replay this video to see the answers. Alright, so now that you've had some time to work them, here are the answers to those 2 practice problems. You can see the factoring, so if you need to pause this and take a look at anything, certainly do. But this would be your final answer for both of them. And that concludes our notes for the second day.